Hey everybody, happy mole day. Today I'm going to be walking you guys through my mole review video, so let's get started. Okay, so problem number 1. It's Halloween and little Timmy has just come back from trick-or-treating. His bag is filled with 2.58 times 10 to the 16 pieces of candy. If 1 mole of candy is equal to 1,000 grams, how many grams of candy you have? So let's start off with what we know. So we're trying to find the grams of candy he has. And we know he has 2.58 times 10 to 16 pieces of candy. So if we start out with the amount of candy we have, and we know that 1 mole is equal to Avogadro's number of candy because it's one of our constants. And then we're also given the information that 1 mole of candy is equal to 1,000 grams. So we bring that up, and then we get our answer. Okay, problem 2. All around town, people have begun to turn into weremoles. The only thing to stop them is through the use of ammonia gas. So if we have 26.0 grams of sodium nitrate and we have an excess of water, how many grams of ammonia gas we can produce? So I actually already have it up here, but the first step I would do is to write your balance equation because we need to be able to figure out the number of moles we have of each substance in order to convert. So now that we have that, start with the 26 grams of sodium nitrate, and then we can look for the molar mass off the periodic table and convert it to moles. And then from there, we know that 1 mole of Na3N is equal to 1 mole of NH3 from our balanced equation. So we can just do a mole-to-mole conversion. And then, since we're looking for grams of ammonia gas, we just go moles to grams. And there's your answer. Okay, problem 3. So Dr. Frankenmole wants to make this Halloween even more spooky by adding slime. Ooh. So we are given the chemical formula for borax, and we're looking for the percent composition. So percent composition is basically just how much of each element is actually in the total molar mass of the whole substance. So if that's the case, the first step I would do is to find the molar mass of each individual substance and then add them all together like I did over here. And then from there, since we're looking for the percent composition, now we take each individual element and put its mass over the total mass to get the percent. And those should be all your answers. Okay. Problem 4. So it's Halloween, everyone's eating candy and they got all hyper. So they want us to find the molecular formula of the substance that is in the candy the kids are eating. So we're given the percent of oxygen, carbon, and hydrogen in it, and we're also given its molar weight. So to find molecular formula, you first have to start out with the empirical formula. And to do that, you have to bring grams. Well, the percent can be brought down and written as a gram. Then you can bring grams to moles. And then you do that for each individual substance. And then, what I did over here is you then divide each piece by the smallest number you had total. And I got 1 for O, 2 for hydrogen, 1 for carbon. That's your empirical formula. And then now what you do with that, you have to find the molar mass of that and find out how many times that molar mass can go into the molar weight of the actual substance itself, which I found goes in 6 times. So we can times every single part of the empirical formula by 6. So now and from there you get the molecular formula of C6H12O6. Last problem. So it's Halloween, and we got the Winifred sisters, who've been released out on the town again. And currently, we know that they've been making a potion that will help them gain their witchy powers back. So in order to stop them and prevent them from gaining power, we want to find out the substance being used. So we're going to look for the empirical formula of the substance. Granted, it contains a certain percent of carbon, a certain percent of hydrogen, and a certain percent of oxygen. So like the last problem, what we're going to do, we're going to bring percent to grams, grams to moles. We're going to do that for each individual one. And then from there, we divide by the smallest. And then in this case, actually, you end up with 1.5 for carbon. And since we can't have a decimal or a fraction in our formulas, we have to multiply it by a number that will give us the closest whole number. And since you do that, you multiply by 2 to get 3, and you have to do that for every other individual one. And then you get C3H8O2. And that is it for my mole review, guys. I hope you enjoyed. Let me know if you have any questions or see any mistakes, and I'll get to it.